Yeah.
Okay, so
Yeah.
test it from backwards and from north to south to left to right, and you're seriously dealing with the giga castings and the mega castings. How thick can you cut? I mean, if you're looking at the, for example, low pressure die casting, other processes where you actually would like to have a neat cut, maybe 15, 20, 25 millimeters of thickness.
Our sweet spot, as we say, is usually between 2 and 40 millimeters.
Okay.
So our preferred, our recommended system would be the PowerMax 105 Sync, and
Mm.
that's 105 amp. And that's going to cut most of the gates. So if we look at all the projects, it's probably going to address 90% of those projects and the gate requirements. Again, as you move from 4,000 ton presses to 9,000 is kind of where we're at now in the industry as the largest, to conceptually and some prototypes of 20,000 ton presses. Again, these parts are getting bigger and bigger and bigger. So it's likely going to require some of the gates, especially in the biscuit area,
Mm.
where you have a lot thicker gates. And especially if they want to scrap or remove the biscuit first, real close to the big round biscuit, you can go to like an XPR system, XPR 300. Or an XPR 460. It'll give you enough amperage to sever the 40 millimeter or even some, larger than that, but we're not
Mm.
encountering those yet. Usually, again, between 2 and 40 millimeters is where we're at now in the industry.
Yeah, most of the, like to Russ's point, most of the runners in the gates, we're not looking at much more than probably 8-9 millimeters. But once you get to those biscuit areas, that's when you start to see, the 1 to 2 inch thick sections where you need to apply more amperage. What's become cool as we've learned more about this industry. I think early on we were really just focused on the Power Max because the thicknesses that we saw probably weren't much more than 17 millimeters. But as we've explored more into this market and talked to more people, that's where we've kind of come into the 40, 50 millimeter thicknesses, primarily as Russ alluded to in the biscuit areas. And scrapping is obviously a big piece of the conversation when you talk to these automakers or even these foundries, because they want to remelt this stuff, they want to recycle the
Mm.
material.
Mm.
And when you use mechanical processes, sometimes the pieces are too big, and how do they go down the conveyor belt? And so with plasma, when you do these thicker pieces, quality isn't as important as maybe just getting the part removed so it can go
Mm.
into a more of a refined process where you can do more intricate cutting. And the biscuit typically is the first thing to be removed because it is so thick and it is so heavy. And like Russ said, we got the XPR that can pretty much lob off that 50 millimeter piece so they can move into some of the more fine cutting where it's much, much, much thinner. And the Power Max system can take care of that.
If we're looking at a gigacast part, there are several applications that plasma it can address. It's cutting the gates off. That's the runner, the overflow. It's removing those finger-like protections. It's cutting those off. It's also reducing the size of those so they can be conveyored out, or so they can fit better in, for shipping or fitting back into the oven to remelt it. And then there's feature cutting. So access holes, grommet holes, shock towers. You cut the circle in the shock
Mm.
tower. And also I think what is critical, and we have technology called a cartridge that will enable this to be automated, and it's to also a continuous pilot arc. So you don't have to start stop at every feature that needs to be cut. So I think, as you guys know and the industry understands for sure, is that molds age. There's flashing that comes out.
Yes. Yes.
So that can be removed. So as long as plasma is, going around the periphery of that part, the pilot arc is on.
Mm.
So it will automatically start and remove any flashing. And as you know, it's going to be in random areas in
Yeah,
each
yeah,
casted
yeah.
part. So that's again showing the flexibility of plasma to overcome that. That's why we're recommending the PowerMax 105 Sync for these applications to our customers. That seems to be the best, well-rounded.
Taking out 1 meter length of flash, how fast can you do 1 meter?
I think when you're talking less than 10 millimeter thicknesses, you're
Yeah.
probably around 24, 25, 100 millimeters a minute. You're talking about cycle time with cutting a full gigacast. You're staying within that 45 second cycle time. If you're referencing a kind of a typical size of a gigacasting, we're meeting a cycle time of roughly 45 seconds or under to cut everything.
And that is with one plasma burner, or do you have several of them in use?
That's a great question.
That's a good question.
So it depends on it all depends on the part. Are they cutting hot? What is the size of the part? Do they want to go around the whole periphery of the part and remove all the flashing? Do they have 3 gates? So, but anyway, so to answer your question, it could be 1 power max, but what we're seeing is, 4 to 6 power max sinks in application. Again, it's what production they need to hit.
Another thing that I want to ask you is that you mentioned that you can also cut the biscuit off and these 40, 50 millimeter thick areas and also the fine cutting. Did you also consider, especially for these gigacastings, you cannot put them in the melting furnace, they're too big to fit through the funnel. So they have to be shredded. Do you also have systems to cut the part in smaller pieces to put into the melting furnace? Because these shredders always break, are heavily expensive, way too loud, and a hazard to operate.
Yeah, I mean, absolutely. That's again back to the flexibility. It's all in the program, right? So you can program it to cut the biscuit off first. So to remove all the weights and and then sequence that with one thing that's really cool is that people are removing a lot of the heat and the weight in the biscuit so they can quench and maintain a temperature.
You have an even cool down and you don't get too much distortion.
Yeah, and the distortion. So it's a ballet, if you will. It's all choreographed. So when you remove the biscuit, when you quench, how many power max? So to meet a 30-second production time, it might move from 2 power max to 4 power max. And the beauty is that they can cut simultaneously and to meet the cycle times. So.
Do you have a vision system for these things, so you actually see or revert back, like I don't know, emission, light, reflection, whatever, to a computer somewhere?
Do we have a vision system for the programming? And that's where we rely on our integrator partners. I mean, they are out there. Our integrators use them. I know that at Hypertherm, I believe in our CTC lab, that's something that we're working on, right, Russ? I know that's kind of our own part of our own internal solutions, but
absolutely.
Here at Hypertherm, we rely heavily on a channel partner that develops the full solution. And so to your point, yes, vision, depending on who that channel partner is, has incorporated that into the cell.
Yeah, it could be a vision system that can identify that particular part, the SKU. Usually in these high volume automation lines that they, it's a dedicated cell. And they'll typically, I shouldn't say typically, we've seen them do a before shot and after shot, just make sure they understand the part dimensions. It sends offsets back to the program, compensates for any significant part variations.
I was thinking about more flash, for example.
You don't need to. That's the beauty. Again, you have a continuous pilot arc that just automatically fires when it sees flash.
You're referring to knowing where the flash is at so that you can trigger the arc
for
to
example.
cut it. Is that what you're saying?
Yeah, for example.
Okay. Yes, and that's the ease of use with plasma. With a laser or other processes, yes, you do need to know exactly where that material starts so that you can send the signal to go. But with plasma, like Russ was referring to, you can think of a pilot arc as essentially when the arc is not initiated, it essentially transfers back to itself or back to the nozzle. So it's like it's always on, if you will. And then once it comes in contact with that part again, like in a welding process, you need to complete that circuit, right? You always have a ground lead that's attached to the part so that electrical circuit is completed. Plasma operates the exact same way. So as long as that pilot arc is initiated and it's attaching back to itself at the nozzle, once it gets to that part that's grounded and that electrical circuit is reinitiated, that pilot arc then transfers from itself to the part and makes the cut. That's why with flash, because it is so inconsistent, a pilot arc basically takes that completely out of the equation and you don't have to worry about it.
Good. Yeah. Completely different area, gentlemen. You are making this equipment and then you have partners like robot companies, automation companies, whatever kind of company that make the application. But if I want to meet someone to talk about the torque. Do you have an office here in Europe, or how is that organized?
Yeah, there's Hypertherm Europe, we have China, we have
Yeah.
Singapore, we have South America. Most of our operations, our manufacturing operations, our corporate headquarters are out of the United States in New England area, New Hampshire to be specific. It's known as like Plasma Upper Valley. Plasma is where it was created here at Dartmouth at first formed, and Hypertherm was a outcome of that. But yes, we have thousands of distributors globally who are authorized to do service support. So service support should not be a concern for anybody looking to use plasma.
So how does it work? You buy a piece of equipment through your partner. They do a nice assembly. You run your production. Do you wear the stuff out after a year, or how does it work? If you run full-time production with a plasma cutter.
Our power sources, we 3 year labor or 3 year warranty on parts and labor for the power source itself. The torches are 1 year warranty, but these power sources operate 100% duty cycle. So I would say that the life of the power source is not a question, specifically from a serviceability aspect of it, and what the duty cycle could handle. But what I'd also say is to have from a maintenance perspective, these are very, let's say, cost effective comparatively speaking to some of the other technologies that are used. And so to have a backup Power Max on hand is not costly whatsoever. And so the plug and play with a new power source, if one does go down, is kind of a no brainer for the maintenance to have. And so these things are going to last years in production.
Well, if I could add to that, these were designed for heavy industry, for the harshest environments as far as humidity, cold temperatures, to work outside in shipyards all over the world in every climate.
And maybe not operated by a brain surgeon either. So
Right. So not brain surgeons running that. Very capable people, I will admit. And they have to pick them up. They have to take them to other levels of the ship. Sometimes they'll throw them over the top. They're robust. They're designed. These are the premium in the industry. They're designed to last forever. I've literally seen systems at shipyards 15 to 20 years old, still running like new.